Hello, my name is Max Weis. I'm going to be describing me and Ryan's final MP project. Our project is loosely based on the famous Conway's Game of Life, in that it is a so-called zero-player game, meaning no user input is taken beyond the initial parameters provided by the player. Our project was created in C++ using a cross-platform library called SFML for its simple graphics, the little event handling we needed, and providing a cross-platform means to create and render windows. The project was made to be built and run on both Windows and Unix-based operating systems, as it has a Visual Studio project file in addition to a make file for compilation in Unix-based operating systems. The project is available on GitHub at this link. The program has 3 parameters to override program default values. These are 2 integers which determine the width and height of the screen, as well as the initial population size, and an additional integer which determines how many frames per second the game will run. Here's a demonstration of a 100 by 100 grid. Here's a demonstration of a 20 by 20 grid slowed to 3 frames per second for demonstration purposes. Here's Ryan for some specifics about the game mechanics.
The large blobs that kind of look like populations are actually made up of tiny individual pixels. Those pixels have a strength value, a team, which is represented by its color, and a location. The strength, however, is a little bit more complicated. In order to understand what it does, first we have to understand how the world updates. First, the world updates each pixel's location. Each pixel will pick a spot next to it. If there is a pixel of another team's color there, it can try to move there. Once it moves there, it will then move on to the next pixel, and it'll do that for all of the pixels. The next step is it checks to see who is in which spot. Remember how I said that one pixel could move to the spot of another pixel? Well, once that happens, the world will compare the strength levels of those 2 pixels. The one with the higher strength value gets to occupy that spot, and the other one dies or loses. Once that happens, for all of the pixels, the world then checks to see if each pixel will reproduce. Each pixel has a 1 in 10 chance of reproducing every step, and it will progenate to one of the 8 squares that surround it.
Here is a demonstration of the default 300 by 300 grid, running ideally at 30 frames per second. The teams battled out for a long time, so I've time-lapsed the game. Quite trippy indeed.